Okay guys, so as we have completed our static routing and default routing, today we are working with our dynamic routing. This is our first lesson with dynamic routing. And guys, you know the benefits of routing, why we need routing, and we already came to know about the types of routing that we have three types of routing: static routing, default routing, and dynamic routing. Okay, so in dynamic routing, we are going to work with RIP version 1 and RIP version 2. We will be having some other details regarding dynamic routing in this lesson. Okay, so let's look around. So these are the topics what we will be covering in our session. Okay. So what is routing? As we already know that the purpose of the routing is to forward the packet from one network to another network. Routing is used to create communication between two different unreachable networks. Routing also help us to find the best path from the routing table to reach from source to destination. So suppose if this user wants to reach some location, right? So Google is reachable via this ISP as well as this ISP. But when the packet will come to your router, so how router will take the decision whether your packet what you are sending from this PC, okay, will be forwarded towards MTN router or MTN ISP or Camtel, okay. So everything it has to decide. So those decision has to be taken by router, but it depends on your routing table and the protocol which is running in your router, okay. The algorithm what that protocol is using. So as we already know that we have some types of routing: interior gateway protocol and exterior. So we have to work with interior gateway protocol. So static is interior, default is interior, and dynamic is interior. So as we have configured our static routing, we have seen that every configuration what we did, and those configuration was manual routing configuration. So whenever you want to add any routes, whenever you want to remove any routes from your network, at that time every single changes or every modification changes has to be done by administrator. Now when we are talking about default routing and static routing, when you are comparing these both, that okay, what is the default difference between these static and default? So in a static, whenever you are creating routing table manually, at that time you have to define the destination network, that okay, I want to reach so and so network. So you have to define that okay, I want to go to A network, B network, C network. So those all networks you have to add in your routing table manually. But okay, so here in a static, whenever you want to reach any specific destination, you are adding those specific destination to your routing table manually. But here what default routing is doing, basically default routings are used for internet access, and in this default routing, it is used to be configured in your router when you want to reach internet, and internet is that you don't know the path, sorry, you don't know the path, as well as you don't know the destination networks, that okay, you want to reach Google, you want to reach Yahoo, but you want to communicate. So at that time when we talk about unknown destination, here static is known destination and default is unknown destination. So when we talk about unknown destination, so at that time we configure default routing. Dynamic is better than, if you compare between static default, so dynamic is better among them. And in dynamic we have three types: distance vector, hybrid routing, and link state. So today we will be talking about distance vector, then hybrid routing, then link state. Okay. And in distance vector we will be talking about RIP version 1 and RIP version 2. Types of routing, as I told you: static, default, dynamic. That default is manual routing with the known destination. Static is manual routing with the known destinations. Default routing is used for unknown destinations. And dynamic routing is a automatic routing with exchanging the routing information with the neighbors to reach to the unknown destinations, okay, depending on its neighbor reachability. Okay, so in dynamic we exchange the information with the neighbors that okay, I am reachable with so and so network. Okay, so you can reach via me, and you share with your connected network, so I can reach to those connected networks via you. Okay, so dynamic routing is also known as adaptive routing. Adaptive routing means it can accept the automatic changes and it can accept the updates from its neighbor. Now it is a technique. Okay, a router adds a new routes, okay, in the routing table for each destination networks. Okay, so when you are using this dynamic routing, so in dynamic routing technology you can say that router adds a specific route towards to the destination in its routing table. So whenever router wants to reach any specific destination, the path is already mentioned or entered in the routing table. So whenever router is crossing or want to reach to a specific destination, it follows the path according to routing table. So dynamic routing protocols are used to discover the new routes. Okay. So dynamic routing protocol also discovers the new routes to reach to the destination. One is already in the routing table, and second what is doing that it also try to discover some better path what is already there in the routing table. Okay, so if any update is coming regarding those destination with the better path, so it will remove the older one and it will add the newer one. So in dynamic routing, we have some specific protocol like RIP, routing information protocol, enhanced interior gateway routing protocol, and OSPF. Okay, open shortest path first. Okay, so these open shortest path first, these routing protocols are used with the ISP with the Hughes network. But RIP and EIGRP, RIP is used for a small, you can say EIGRP used for medium, and OSPF is used for large organization. Okay, and if a route goes down, so when we are talking about dynamic routing, so if any routes towards the destination go down, okay, then the automatic adjustment will be made to reach that destination. It is automatic, no need for manual that okay, something is down, let me add some new routes as we did in static routing. So this is not in your dynamic routing. The dynamic routing protocol should have some following features. Okay, the routing protocols, like the neighbor, like when you want to communicate and exchange the information with your neighbor, so neighbor routing protocol and your routing protocol must match to exchange the information. Okay, so now when we are talking about some neighbor routing, okay, so suppose if I want to exchange some information with the neighbors, right? So those routing, okay, suppose my neighbor, I'm running RIP, so my neighbor should also run RIP. Okay, then I can update and then I can exchange the information with that neighbor. Otherwise it will not work by default. You have to make some changes. Okay, it's very simple. If I'm communicating in English, okay, so you should also communicate to English so we can understand. It's not that I'm talking in English and you are talking in French, so we cannot understand. You will not understand my language and I will not understand your language. So here in the dynamic routing is saying that routing protocol must be same to exchange the information. Okay, and if the router discovers any changes in the conditions or topology, then router broadcast or multicast the information to all the routers to have a new update. Means if any link is down to with your router and your router needs some specific path to reach some destination, so it will send some query message to neighbors that please I have I lost the link or path towards this destination. Please, if you have any path, you can give it to me so I can reach there. So this is the dynamic routing feature, and that you already know that we have three type of dynamic routing: RIP, EIGRP, OSPF. So this feature what we are talking, it is for RIP also, EIGRP also, and OSPF also. Okay, and after this dynamic routing introduction, we will be talking only about RIP. Okay, so in dynamic routing, table is created. That routing table is created, maintained, and updated by routing protocols running on the router. So as we have seen in our static and default, we used to create some routing tables, but here everything is will be maintained by routing protocol itself. Examples of those routing protocols: RIP, EIGRP, OSPF. Router do share dynamic routing informations always, okay, which each other with your neighbors, you can say. And while these kinds of information sharing will utilize your CPU, RAM, and bandwidth, of course, some process will run in your router or in your system, of course CPU utilization will be there, RAM utilization will be there. Okay, but you can say that um, like better will be like EIGRP and OSPF is better as compared to RIP, because uh, RIP has higher CPU and RAM utilization, bandwidth utilization as compared to EIGRP and OSPF. After some slides, you will come to know why this is happening there. Dynamic protocols are capable of dynamically choosing a different or better path when there is a chance of routing domain. Okay, sorry, there is a change of routing domain. We have already talked about this one, that see, if in this one we have talked, see here, if some better route will come, so this is my old route, and if some better route is coming towards you, so it will remove the old route and it will discover the new route and it will follow the new route. Okay, so here also is saying that whenever some changes is there, it will update the changes in the routing table, okay, with the better path. So it will compare, suppose if I'm getting some new update, and in that new update I have some better path to reach destination, so of course I will remove the older one and I will put the new one in my topology table, or you can say routing table. Dynamic routing protocols here, it's shares the routing table information to its neighbor. Okay, and which type of information they share, they share about the connected networks. Okay, so that you can say that, okay, I am reachable to 5 networks. Okay, so those information they share with the neighbor, and neighbor also share the routing table with you. Okay, so you directly communicate with the information what you are getting from the neighbor. Because see, if you want to reach Google, so your company router is not directly connected to Google, right? So you have to follow some kind of path and information received via your neighbors, right? I means you have to rely on your neighbors. And how you can rely on your neighbors? Due to your same routing protocol which is running on your neighbors. Okay, or some kind of authentication, authorization kind of. So you have to rely on your neighbors. Security method, we will talk on that. Okay, now we are talking here advantage and disadvantage. So advantage is that it is easier to configure. It is faster to find best and alternate path to reach to destination network. It is more effective in selecting best route in response of changing in the means if there is some changes in the topology. So it is best and faster as compared to your static and default. And disadvantage is what you can say, it is a little bit expensive in terms of CPU and bandwidth utilization. Of course, if some process will run, so of course it will utilize your CPU and your bandwidth. It is a less secure as compared to default and static. Okay, so static and default, you can say there is no any kind of security mechanism, but in RIP, yes, there is security mechanism, that if you want to send update to your neighbor, okay, so you can put some kind of authentication, authorization, okay, to secure your routing domain. Now if we are talking about some categories in our dynamic routing, so Dynamic routing has some categories like I told you distance vector protocol. Means dynamic routing is divided into three section, which is known as distance vector protocol, and RIP and IGP is a distance vector protocol, but IGP is not in use. Okay, I think before they stopped using IGP like before 15 year, or not 15 year, I think before 10 years ago. IGP was there, but they are not using IGP. Even routers are also not supporting IGP, but RIP is in use nowadays. So they talk about like RIP and IGRP is the part of distance vector protocol, and OSPF and ISIS is a part of link state protocol, and hybrid routing is a part of IGRP. And why it is hybrid, when we will come to know slowly, okay, about these relations, you will know why they called it hybrid, why they called it link state. But today we are talking about distance vector, so we will come to know about only this section. Okay, why it is known as a distance vector, and the now let's talk about, now we are talking about RIP, routing information protocol, distance vector routing protocol. Okay, so RIP is a distance vector routing protocol. So distance vector routing protocol use periodic update distance vector. See, it's not saying, now it's not saying dynamic routing protocol. See here, you can see that dynamic routing protocol is divided into three sections. One is default, distance vector, hybrid, and link state. So now we are talking about distance vector. And as we know that when we are talking about distance vector, means we are talking about RIP, because IGRP is not in use. Okay, so distance vector routing protocol, or you can say RIP, use periodic updates of the full routing table and send to its routing neighbor. Means suppose if you are my friend, okay, you are my neighbor. So after, like, after 30 seconds, they, okay, here it's here, means after 30 seconds I will tell you about myself. Okay, my name is this, I live here, I live here. Okay, this is my country, this is my language. So after 30 seconds I'll be sending you the same information. Okay, and it is periodic. After 30 seconds same information, after 30 seconds same information. So I'll be utilizing my CPU. Okay, and when you will receive those updates, you will also utilize your CPU, and we will be utilizing the bandwidth also. Okay, because unnecessary, you have already informed me about you. Okay, I know you. Now after 30 seconds you will be telling me, okay, my name is Paul, my name is Paul, I live here, I live there. Okay, so you are wasting the bandwidth, right? So same here. Okay, distance vector protocol suffers from slow conversions. Okay, means if there is any changes, so it updates to its neighbor. Okay, so in 30 seconds or after 30 seconds, you can say, like if there is changes, so conversion is slow, and due to this slow convergence there is a high risk of loop. Okay, loop means there will be a loop in the network, and maybe your network can go down. A distance vector routing protocol, okay, begins by advertising directly connected networks to its neighbor. So whenever you want to create a topology of the network where each and every computer should communicate, so your router, means like router 1, router 2, they share the information which is directly connected to you. Okay, or the information which is in your routing table. You share your routing table to this router shares his own routing tables to you, and then if every share, means exchanging is completed, then you will have the fully converse routing table. Okay, and I already told you that the update is regular, means after 30 seconds regularly you will be receiving the routing updates. Now neighbors will add the routes from the updates what it has received from you in its routing table. Distance vector protocol utilize some form of distance to calculate the route matrix. Now here distance vector, it calculates some kind of distance to find the best path to reach a specific destination. So if I'm receiving same information from two different neighbor, Okay, suppose if let me open here. Okay, so suppose here is your company router. This is your company router, and your company router is receiving some kind of information from. This is one kind of ISP. Okay, you can say this is ISP1, ISP1, and you can say this is ISP2. Okay, now when your router is receiving these kinds of information from these two ISPs, information about Google, information about Google, and here your router will keep those information in the routing table. Now what will happen? Now when this PC will send a request that okay, I want to reach Google, so information came to you. Now your router, how your router will decide whether the packet should be forwarded to ISP1 to reach Google, or the packet should be forwarded to ISP2 to reach Google. Okay, so those all informations will be kept in the routing table. Okay, so whenever your router is getting information regarding Google from ISP1 and ISP2, so your router will compare that okay, I received two information for same destination, so which path is best. Okay, so those path calculation is known as metric. Okay, and distance vector use distance kind of calculation method in the metric, and those distance calculation is known as hops. That okay, I'm reachable to you after 2 hop, 3 hop, like that. Okay, hop, how hop you will understand. See how hop we are understanding. See, suppose if this router is sending some kind of information, so this is known as 1 hop. Okay, this is known as 1 hop, and this is also known as 1 hop. Means if I have, like for example, let me take some routers here. One router, two router, three router, four router, and here is one destination computer where I want to reach and communicate, and they all are connected. Okay, with the cables, these all routers are connected. Connected, 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 and this is the router 1, this is router 2, router 3, and router 4. So suppose you are here. Okay, your computer is here, and you want to reach to this computer, right? So this is the destination. So what will happen when you send a packet here? Okay, so this is known as 1 hop, 2 hop, 3 hop, 4 hop, 5 hop. Means after 5 hop, you reached to the destination you wanted to reach. Like see, okay, 1 hop, 2 hop, 3 hop, 4 hop, 5 hop. Okay, so the one network to another network, okay, or you can say one router to another router is known as hop. Okay, one jump to another jump means your packet has jumped from your top PC, reached to one router 1, router 1 to router 2, router 2 to router 3, router 3 to router 4, and then PC. So total we have 1 hop, 2 hop, 3, 4, and final destination 5 hops. Okay, So if your source distance and destination distance is between 15 hop, okay, in between 15 hop means you can reach to the destination. But if it is more than 15, if it is 16, 17 hop, means your destination is unreachable, means you cannot communicate to that destination. Okay, now some other informations regarding RIP. RIP is used RIP is a standardized distance vector routing protocol. Standardized means you can use RIP on any type of router, whether it is a MikroTik router, whether it is Juniper router. It's an open standard. Means you can use it on any kind of device. Okay, and it is used to. It is designed for a smaller network, not designed for the large network. Okay, RIP was one of the first true distance routing protocol. Means when we talk about a static and dynamic default, and then we are talking about dynamic. So in dynamic, as I told you that we have distance vector, then we have hybrid, then we have link state. So when they developed about this dynamic routing protocol, so at that time, means RIP was the first dynamic routing protocol. Okay, and it used to support wide variety of systems. Means it is open standard and it can be used on any kind of routing device. Okay, it's not proprietary like EIGRP. Like EIGRP is a Cisco proprietary protocol, okay, but RIP is open standard protocol. Now RIP can be used for a smaller organization because it supports only 15 hops, which is known as gateway already. 15 hop counts. It cannot cross more than 15. It, when it will try to reach in any destination, and that destination is more than 15 hop away, means that destination is not reachable via the router which is using RIP. Okay, RIP use some kind of any kind of communication when you are uh, using or when your network is using any kind of service or communication. So all those service and communication is both based on some kind of port number and protocol. So like see, when we are talking about RIP is what? RIP is protocol. So every protocol have some port number. Okay, and RIP use UDP port number 520. Okay, and this port number is used for sending the updates to the neighbor and receiving the updates from your neighbor. Okay, by default RIP supports for equal path cost load balancing. uh, Load balancing, you will understand, we have separate session for this one. Load balancing means like when we are talking about like this. Okay, suppose if you have some kind of, suppose this is your router and your router had two path. This, okay, two path. One is path towards ISP1 and second path towards ISP2, right? So normally by default your router will choose one as a best path and second link as a second ISP as a second best path. So whenever your router will receive any data, it will send it will send only via primary path, okay, which is best. Okay, so whenever data is coming, it is forwarding from here, forwarding from here, forwarding from here. If this route system is also sending, it is forwarding from here, forwarding from here, like that, right? But maybe this link will never go down. Suppose why we have multiple paths. Suppose if this link is down, then your router will choose this link, right? But for example, if this link has never gone down for last 6 months, okay, so your company will be paying for 6 months to this ISP, and this link was on unused, because this link you kept two link for your network communication to reach internet. One was primary and one was secondary. For redundancy, if the primary fails, your company data can reach to internet via secondary link, right? But this primary link has never gone down for last 6 months, so you have been paying to ISP, this ISP, right? So you as a network administrator, you wasted the company money. So what, as a smart network engineer, what you can do, you can say that okay, half of the network traffic can go via link 1 or ISP1, or half of your network traffic can reach to ISP via this link. Okay. So this is known as load balancing. So we will be talking about load balancing separate session. Now RIP routing protocol share its locally connected networks to its neighbor. Okay, and once neighbor that get the details of the received routing information, okay, and after that they will create its own routing table and start communication will start. Now some other features. Okay, so we have already talked about this one, that okay, the RIP sends the periodic routing table updates to its neighbor in every 30 seconds, and it is periodic. 30 seconds you will be receiving the updates. Now when we are talking about RIP use a form of distance as a metric to calculate the best path to reach destination, and the form of metric is known as hop count. RIP use UDP port number 520. We already know about this one. Yes, this is a new thing, and when we have talked about some kind of metric calculation, at that time we already came to know about administrative distance. So each and every routing protocol have some kind of numbers. With those numbers, okay, this number is used to compare that which one is best. Okay, so just I'm just giving you a small like little example here. Okay, and in future you will know the real use of administrative distance. Like suppose I'm using RIP. Suppose my router is using RIP. Maybe I have three car. One is RIP car, second one is EIGRP car, and third one is OSPF car. So if I want to reach some specific destination, if I want to reach Banjul, okay, from Fazara, so I have RIP car, I have EIGRP, OSPF car. Now RIP car use 120 minutes to reach Banjul. EIGRP car will take 90 minutes to reach Banjul, and OSPF car will take 110 minutes to reach Banjul. Now which one is the lowest one? So you can say EIGRP will take lowest time. So automatically your router will check, okay, and compare that, okay, which routing administrative distance is lower. Okay, so you'll say okay, EIGRP is 90, RIP is 120, and OSPF is 110. So which one has the lowest one? So EIGRP has the lowest one, so it will consider this and it will reach to the neighbor with the EIGRP protocol. Okay, so it consider every routing protocol has those numbers predefined. Okay, if you want you can change. Now any network that is reachable to the destination after 16 hop away, okay, it will consider unreachable. Means I know that okay, Paul is after 16 gateway, after 16 hop, I know, but I cannot communicate to you because my limitation is only 15 gateway. Okay, so any destination which is 16 hop away, that is considered as a poison route or infinity matrix. Or if any link will go down, okay, your router will start advertising to its neighbor that that network is down. Okay, I'm not able to reach that network. So normally in the network, the routers advertise that that network is poison route or infinity matrix. So whenever you will receive any kind of message regarding poison route or infinity matrix, means you are not reachable to that networks. So RIP has some versions, RIP version 1 and RIP version 2. Okay. So RIP version 1 is a classful routing protocol. Classful routing protocol means it supports default route network like class A, class B, class C. Okay, it do not support any kind of subnetting. But here RIP version 2 supports classless and classful both, means it support normal network as well as subnetted networks. And nowadays you RIP is 1 is not in use, RIP 2 is in use. Why? Because uh, you will find everywhere subnetted network everywhere. It's not that no one use default network nowadays. RIP version 1 send the routing updates information to its neighbor using the broadcast uh, IP address, and you can say broadcast address. So that is 255.255.255.255. But when RIP2 is sending, sorry, the information is wrong here. Let me change. RIP2 use to send updates with multicast address. Multicast address, and it use 192.224.0.0.9, and it used to communicate with its neighbor. Okay, now okay, so here we already came to know about RIP version 1 difference, RIP 2 difference. RIP 1 use this broadcast address to communicate with its same version routers. When RIP2 wants to communicate to its neighbor, RIP2 neighbor, they use multicast address. Multicast address. And here you will come to know that there are some kind of network, every network is different. Like your company network will be different as compared to another company networks. Okay. So whenever any companies are trying to communicate, okay, and use some kind of networks, so they have some kind of contiguous networks and discontiguous networks. Okay, so when we will do some kind of lab at that time, we will understand. Okay, so in RIP1, if you are using discontiguous network, so it will not work here. And RIP version 2 supports contiguous network and discontiguous network as well. Contiguous network and discontiguous network means, if you are taking this example, okay, see here we are using some kind of 1 here, 13 here, 12 here, 192. So these are discontiguous network. Contiguous network is I'm using same network, subnetted network. Here I'm using 192.168.10.0/24, 20.0/24, 30.0/24, 40.0/24, 50.0/24, like that. Okay. And last comparison is like RIP version 1 do not support any kind of authentication, and here RIP version 2 supports authentication to, like, when they exchange some information with the neighbors, they use some kind of authentications. Okay, now RIP routing protocols, some other process, that RIP routing protocol builds the routing table based on the update received by its directly connected neighbors. Same information what we talked, so it's just a revision here. Okay. Now here, if you are talking about some kind of configuration, that okay, how to configure RIP version 1 and RIP version 2. Okay, so this is the commands to configure RIP version 1, and this is the command to configure RIP version 2. Okay, so here we have some labs. Now we are on the practical session. So now we are going to configure RIP version 1, then slowly RIP version 2, like that. Okay, so let's work on the RIP version 1 lab. So here we have GNS3. So let me write RIP version 1 lab 1. So here you can take like 2 routers, 3 routers. Okay, so we are taking 3 routers. Okay, router 1, router 2, and router 3. Now we can take some switches here. Change the symbol to the real switch. So see, this is your layer 2 switch. Normally we use layer 2 switches in our network. Okay, fine. Now we are taking some computers. PC1, PC2. Now we are connecting it. So from router, if I want to connect router 1 to router 2, I am using serial 0 by 0 to serial 0 by 0. Serial 3, router 3 to router 2. Okay, wait, let's delete this link. Let's put router 2 here, then router 3 instead of getting confused. Serial 0, serial 0, serial 3 0, serial 3 0. Okay, and it's not that you should use that link. Okay, I'm using it. Okay, you can use any link to connect. Means you just need a cable to connect that device. That's it. There's no kind of you can say that we need a specific type of port number. No, cable, you know that for same device and different device. In our cable section, we have already came to know those things. Okay, that if I want to use. Okay, just a second. Okay, so cable from same device like router to router. Okay, we are using here serial cable, and here we are using Ethernet and fast Ethernet cable. Okay, you click here for having your port numbers 30, 20, 30, Ethernet. This is not important. This is also not important. See, sometime when you design perfect lab, right, it takes some time. Okay, so why I'm taking time, right? Because I want that you should see how to configure perfect lab. Okay, so everything is okay. Now we are just going to define some kind of network. So here if I am saying that 12.1.1.0 slash thought, okay, it's RIP1. So I can say that, okay, let's use default, as it do not support subnetted networks. Okay, fine. Here I can use, instead of 12, here we have 23, and then here we can use some networks. One 192.168.10.0 slash 24. Okay, and this is your LAN network, you can say. This is your LAN network. Okay, and here we are using slash. Okay, so here in this is your LAN. Okay, so here you are using as a slash, like 20 network. Here you are using slash 10 network. Okay, class C 10 network is different and 20 network is different. Now here with this PC, here we are using 192. This is IP address 10.1. Okay, let me, okay, this is 10.1. Now here we are using 10.2. Here we are using 20.2 and then 20.1. Okay, and as this is your interface, okay, so here we are using as a 10.10 as a interface IP of your router, which will be used as the default gateway. Okay, 20.10. Fine, and here we are using our RIP version 1 routing. See how simple it is. So see the process, let me write all the process again. Any kind of routing configuration, if you are trying to configure, so the first process is design your network. Okay, the first is that you have designed your network. Second, after designing your network, okay, connect with correct correct cables. Third, define networks of your devices. After defining the network, the fourth section is configure the interface IP address. Okay, and after configure the interface IP address, then the fifth number is configure the routing, okay, and sixth number is test the or verify the communication. Test the communication from one network to another network, okay, from you can say PC1 to PC3 like that, okay. So this is the section like whenever you want to configure any kind of lab, so this is the proper section, okay. So if you follow this section, you can easily define the lab and successfully your lab will be working and you can understand the process as well. So let's start our all the devices after connecting, designing to configure. Okay, so our devices started, interfaces are also fine, connected, op and like that, okay, no problem. Now let's take a console. If you're clicking here, you will have the console access of your devices. So as you have PC1, PC2, PC3, PC4. So PC1, PC2. After that you have router 1, then router 2, then router 3, and then PC3 and PC4. So let's come to your PC1 and define the network. So it's very simple. Type IP 192.168.10.1/24 and the gateway is 10.10. Save the configuration. Now come to your PC2, save. Now come to your router 1. So on router 1 you can see that you have two interface. One is serial 2 by 0 connecting towards R2 and second one is E0 by 0 which is connecting to the switch of your LAN. So you can see here conf t interface serial 0 serial 2/0 IP address 12.1.1.1 what we have decided and the subnet mask is 255.2.0.0.0.0 like that, okay. No shut down means to enable the interface, shut means to disable the interface, no shut is enable the interface. So your serial 2/0 is configured. Now exit. Now second interface port is up. Now we are coming here interface E0 by 0 IP address 192.168.10.10 subnet mask and then no shutdown. Exit, exit and save the configuration. Right, right, okay. So I have saved the configuration. What command I have used here? See here I have used these commands. These, see, whenever you see in something after hash, that is a command. See, this is not a command, this is an update of the configuration what you did, okay. After a star, if these messages which is coming after like a star, so these are updates, the information regarding your changes, okay. And after hash or something, that whatever you are getting, so those are commands, okay. Like see, this is the command to save the configuration. So our R1 configuration is completed. Now we are moving to R2. So R2 has two interface, serial 2 by 0 and serial 3 by 0. So I'll come here conf t interface serial 3 by 0 IP address 23.1.1.1.255.0.0.0 no shutdown. Then I can write exit. Okay, update came. Then interface serial 2 by 0 IP address 12.1.1.2 255.0000 no shutdown. Exit. Okay, now you come to your router 3. So still we are configuring IP addresses. Conf t interface serial 3/0 IP address 23.11.1.2 255.0.0.0 no shutdown. Exit. And now come here, interface E0 by 0 of your router 3 connecting towards your LAN address 192.168.20.10 255.255.255.0 no shutdown. Okay, your ports are up now, configuration is completed. Now save the configuration. Did I saved on R2? No. Let's save the configuration. So R1 configuration, R2 configuration and R3 configuration is saved. Now come to PC3. So IP 192.168.20.1 subnet mask gateway. PC4. Let's configure like that. That will be easiest for us. PC4 is 20.4 and PC3 is 20.3. Here will be 20.3 and here will be 20.4. Okay, fine. Now if I'm coming to my PC1, okay, now test the communication as we before configuring routing. So suppose PC1 wants to communicate to PC4 which belongs to a different network. So if you want to check your IP address, type so IP, your IP is 10.1. And now if you're trying to communicate 20.4, you'll get some message that destination is unreachable. Means the destination to which you want to communicate, it is unreachable, right? And when it is unreachable, you cannot communicate, right? Are you understanding? So when you are not able to communicate, what you have to configure? So you have to configure routing. So where you have to configure routing? See, PC1 wants to communicate to this PC4. So when PC1 is trying to send data to R1, R1 is saying, okay, wait, let me check that do I am reachable to that network. So R1 will check its routing table. Say come to R1, show IP route. R1 is checking its routing table and saying that okay, I do not have any kind of route or routes towards that network. See, I don't know about 20. See, I do not have. So what you have to configure? You have to configure routing. So as we are configuring RIP version 1, so you have to come here, conf t router RIP. Okay. Then here you have to say network. Okay. Network is that no, see, locally connected, you have to advertise your locally connected network. So how many locally connected networks you have? So you can see that you have one is 12 network which is directly connected to you, and second one is 10.0 network, 192.168.10.0 network, which is directly connected to you. So you have to advertise your directly connected network, and you can see here L, okay, C, okay. So this is your directly connected network, so you have to advertise this network. So let's advertise. So come to your network and type 12.1.1.0. if you want to advertise like this what you have given in your uh, scenario, or you can connect, you can type this one, okay, no problem, because this is RIP version 1, okay. So let's type this one, but and now it is network is done, this network. Now it is asking, okay, second one. So second one is 192.168.10.0, and then exit. See how simple. Now if you are coming to your RIP2 router 2, sorry, here also you type here, so IP route, okay. So all routers by default they know about their own directly connected networks, okay. So they don't know about the networks which is connected to its neighbor. See, router 2 do not know about 10 and 20, okay. So here you have to configure routing again for this one, router RIP network. So here you cannot write that I want to reach so and so network, you have to advertise your network, totally opposite as compared to static, okay. In a static we are writing that I want to reach that specific network. Here you have to write that I my network is this, simple, 1 12 and 23, that's it. Now come to R3 conft, same here also if you want to verify, so IP route, okay, then type here conft router RIP, router RIP network. I have directly connected network which is 23, and one is 192.168.20.0, and then exit. And now you can see if you are coming to your router 1, and now if you are verifying your routing table, you can check your routing table. Now it is totally different. So IP route, see here you're getting some information like R means RIP, right? Means now you are reachable to this network and this network with the help of RIP, okay. Now R means RIP. Now see, RIP is saying that you can reach to this network, and that network administrative distance is 120, means it is RIP. After 2 hop, after 2 hop means, see, 1 means from router 1, because we are checking routing table of router 1, 1 hop, 2 hop, okay. Means after 2 routers you can reach to that network. And is router 1 is saying that if whenever you want to send, means router 1 wants to send any information towards this network, so drop packet to the neighbor, and this is serial switch to neighbor, I means this is a switch to IP, okay. And that network information I got updated before 13 seconds, and if you check again there will be something different, okay. But it cannot reach more than 30 seconds, okay. See, after 20 seconds you will find the same thing, is after 30 seconds it will be refreshed every time, okay. And that neighbor is connected to my serial 2/0. And now when updates of your all routers, you can check here, so IP route, now all routers know about everything. See, All routers know about the topology now. Now router 3, see here, okay, fine. You can see here 12, 23, 192, 168, 10.0, 20.0 like that. Now if PC1 wants to communicate, see the communication is there, okay. So now PC1 is communicating to PC4 with the help of routing table. Now here we have something to verify, that for example, as I told you that RIP version 1 sends the routing updates to its neighbor periodically in every 30 seconds, right? And when routers sends the information, RIP information to its neighbor in RIP version 1, they use 255, 255, 255, 255 broadcast address, right? So this we have to verify. So let's verify this one. So what you have to do, you have to come to router 1 and you simply say that let's come to router 2 and simply run this debug command. Debug IP rip updates, no, okay, events, just type debug rip. Let's see, debug IP rip, okay, received update from this, sending update to this, okay, fine, sending, and you all to update the stop this kind of messages. Now we just wanted to have the information. See, now you can see that you can say that uh, R2 is saying that I received version 1 update from 23.11.12 means router 3 on my serial 3/0, on serial 3/0 here. Now is saying that I am sending RIP update version 1 to, it's not define any neighbor. She's saying that I am sending to the broadcast, and whoever is working in this broadcast domain, they, and if they are understanding RIP language, they could get the updates, okay. So the updates were, see, sending update is see here, are you getting, receiving will be not via this. See, receiving means what, this, that is not a IP address, right? Okay, sending means I can say, I can shout, okay, but receiving must have some port, okay. So receiving will be on the specific IP and port, but sending, I'm sending on broadcast, so whoever work in RIP, they could get the updates, okay. And here they are advertising about metric means one hop, means, see, is saying that let's talk about this one, metric 2, saying that router 2 is saying that whenever anyone wants to reach 10.0 network, that is 2 metric away from me, so you can see here, route here is one hop, two hop, okay, after two hop you can reach there, okay. So these informations they will be sharing in the networks, and whoever works with RIP, they will be getting the updates and changing their routing tables depending on these updates, okay. Now RIP1 is completed. If you want to verify some other things in RIP, okay, so let's come again. Now suppose we are here now. Suppose if I'm on router 2 and I want to know that about protocol which is running on my router, so I can come here, so IP route, so you can see here this is your routing table, and if you are typing here, so IP protocol, okay, so see here your routing protocol is running, okay, and these are your interface which is participating in your routing domain. So okay, you are using version 1. Okay, so by default version 1 can, this will, you'll know that okay, do version 1 can communicate to version 2. Yes, version 1 can communicate to version 2, but version 2 cannot communicate to version 1. Okay, so this, we have a separate lab for this one. Here you can say that yes, I have two routing which is locally connected, and this is my neighbor information. So whenever you want to know about your neighbor, so you see router 2 have two neighbor. So 12.1.1 is the IP of router 1, and 23.1.1.2 IP is router 3 IP address, and the distance is administrative distance and the last update. Okay, so this is the from last updated means from last you communicated to this neighbor. Okay, so in RIP version 1 there is no much information. It's very simple to communicate. Okay, now we have checked this one, that some show commands, that show IP route. So IP route will show you the routing tables of the router. So IP protocols will show you the protocol which is running on the router. Okay, now we have some other commands, that okay, so IP route rip. Okay, so let me show you some other commands as well, the output of those commands. So if I am on router 2, and suppose if I'm running this command, so IP route, so here I'm getting whole routing information or whole network information connected and rip. See, connected means these are my local networks, so I cannot bother about these things. Okay, because they are my locally connected networks. But we are working on this one, right? So I will say that maybe, see, this is a small, scenario. If you have a large scenario, then where you have multiple lab, like routers, like 10 routers or something like that, in that your routing table will be very large. So how you can get only specific information what you want from routing table. So I'll say that okay, please show me only RIP network, not my all directly connected. So you just summarize and type router RIP. So here you will get only your RIP networks, not your directly connected networks. Okay, and this command we have already came to know that okay, so IP interface brief exclude unassigned means your network information, right? Okay, now maybe you will say that okay, I know, I want to know the status of my serial 2/0 which is connecting to router 1. So you just write this one, so IP interface brief, okay, include serial 2/0. Okay, so it's not showing here. Yeah. Okay, include serial, include 0 by 0. Okay, include serial to serial 2/0. Okay, no problem. So include will give you some options, like see what we have used here, include, so IP address, in, exclude unassigned, exclude unassigned, like that. Okay, so you can use this. Slowly you will come to know these sections, commands. Okay, debug command we have already seen that okay, to check the process which is running behind the scene. You can, the process, see process, like see router 1 is communicating to router 2, but we cannot see these things, and whenever you want to see those things you have to run debugging command to check the processes also. But debugging just used for testing purpose and close it, otherwise it will utilize your entire memory. Okay, now If I want to check some other informations like so run section router. See, so which type of routing command I'm running? So these are sections. See, if I'm writing here so run, okay, so run will give you long information, okay. But if I want to know only routing informations, what configuration I did in routing, so you can summarize it, you can say, okay. So commands is also completed. So commands are used to get the details of your configuration, what you have configured, okay. Now verify, we have already verified with the debugging, okay, and we verified the broadcast address, how they are communicating, okay. Now we will work on RIP2 configuration, okay, and we'll know the why we need RIP2 instead of RIP1, right? Because RIP1 is also helping us to communicate. Then what is the need of RIP2? Now in the same lab I'm explaining you the RIP2, okay. Okay, so no problem. So first let me remove those default routing and okay. So if I'm coming on router 1, so first of all, if I want to remove RIP1, so I'll come here conf t no router RIP simple command to remove RIP routing. If I'm coming to router 2, conf t no router RIP, router 3 conf t no router RIP. Okay. Now if I'm coming on PC router 1 and typing here so IP protocol, see nothing is running, no RIP, nothing. Okay, and if in PC1 is trying to communicate, no communication because I have removed the routing. But now here we will see that need of RIP version 2. First understand why we need, then we will talk about RIP2, okay, configuration, okay. First let's see the problem in the RIP1, okay, need of RIP2, okay, due to problem, due to subnetted network problem, okay. Let's delete this one, no need of RIP2 due to classless network communication, network communication, okay, classless network communication. So classless means subnetted. So here, okay, the network what we are using here, is it subnetted network? No. But here if what I will do, if I'll come here on this, instead of 24, if I will use here 26, right? And here if I'm coming here instead of this, okay, and here I'm using 64/26. This is subnetted. If you know about my subnetting class, okay. So here will be okay, 10.2 fine, here is 10.10, here is uh, here I can come to, I can say 10.65 fine, okay, or say 100 is okay, but here will be 10.10 65. Okay, and here will be 10.75. Okay, so when we are using this /26, so the subnet mask what you have to use 192. So this will be the subnet mask. This will be the subnet mask. Okay, and this will be the network for the net for the. Okay, fine. So here also this is the subnet mask with /26, and this is the network. Okay, fine. So configuration we have to change. So let's come to your router 1 from PC1 as well. So PC1 you have to change. So you have to come here IP 192.168.10.1/26, and the gateway is okay, no problem, 10.10. Copy, come to PC2. Here will be 10.2. Instead of /24 it is /26. Fine. Now router 1. Conf T. Serial is okay, serial 2 is okay, no problem. Only Ethernet 0 will be changed. So I'll come here, interface E0/0, IP address is 192.168.10.10, no problem, but only the subnet mask is changed 192. Fine, no shit. Other things are okay, no problem. Serial 2 is okay. Router 2 no changes, only router 3. Conf T. Now here I'll come here, interface E0/0, IP address 192.168.10.100. Subnet mask is subnet. You can say it's classless. Okay, no shit. Other is okay, fine. PC3 IP is changed, so I'll come here, IP 192.168.10.65/26, and the gateway is 10.100. Fine, I'm not going to save it, let it be like that. Come to PC4. Here will be 70. Fine. Now same here, when PC1 wants to communicate 10.70 IP, no communication. Okay, destination host on the. Why? Because when you're coming to your router and checking here, show IP route, okay, so IP route, no information here. So what you will do, you'll say, okay, let's configure our RIP routing, right? So you'll say, okay, RIP version 1. So you'll come here, let's configure. So I'll come here, conf T router RIP. Network, I have 12.1.1.0, and second network is 192.168.10.0, because there is no any kind of subnet information. So you just write it, exit. Now come to router 2, no changes because okay, here from here we have removed the, no problem. Let's configure here router RIP network 12.1.1.0 and network 20.23.0 and then exit. Fine. Now come to your router 3. Conf T router RIP network 23 and network 192.168.10.64. Okay, and then exit. Okay, this is a subnetted one. Now if I'm coming to R1 and check my routing table, so IP route, see, do you have any information regarding 64? But you have configured routing. And if on PC1, if you are trying to communicate, still it is unreachable. See, here also PC router 3, if you're checking here, so IP route, see here, no communication. See, you have 64, you have 100, okay, but you are not exchanging with the, okay. See, now if you see here confusion, if I'm coming here, show IP route, see, now your router 2 is saying that if you want to communicate to 10, I have two gateway, one is 23 and 12. So what is saying here, if I want to communicate, okay, so if any data will come to your router 2, so router 2 is saying that whenever you want to communicate to 10, you can go via R1 as well as R3, right? But it's wrong. If you want to communicate 10.0/26, then you can go via this, and if you want to communicate 10/64 subnet, then you can go and communicate via this one. But here your routers, okay, in RIP1, they are not understanding about classless network. They always understand about classful. See, you are advertising /26, right, from R3, but R1 and R2 they are understanding as a /24. See, you are advertising as a /26 and they are understanding as a /24, which is classful. And that case, if you will come on router 1 and then you will say, okay, no problem, let me configure router version 2, RIP version 2. So router RIP version 2, okay, network, same network, okay, and then network is 192.168.10.0. Here you have to write no auto summary. No auto summary means do not summarize whatever I am advertising, advertise that one. If I am advertising /26, advertise /26. Do not summarize as a default, okay. Simple. If you come to router 2 conf t, type here router RIP version 2 network 12.1.1.0 network 23.110 no auto summary. Okay, fine. Come to R3 conf t router RIP version 2 network 23 network 192.168.10.64 and then exit. And once it is advertised, and now if you'll see here and try to communicate, after some time when the conversions will complete, you will see that they are communicating. Piece router 1, let's see. So IP route, so IP protocol, yes, version 2 is running. So IP protocols version 2 is running. Okay, router 3, so IP protocols version 2 gateway is this, advertise network is Still no communication. PC 192.168.10.65. Gateway is also fine, no problem in the gateway. Let's come to router 1 and try to communicate. Maybe some 192.168.10.70. So IP route. No, you are not getting routes. You are getting only 23. But no, why you are not getting R3? You have advertised routing for 23 and this R2. So IP protocols. You have advertised this R3. And everyone has advertised about that. Okay. See, I told you that RIP has the slowest conversions, right? So actually they were conversing about this. So it took, see, normally this will take 30 seconds, then this will take 30 seconds to send. So 30 seconds, they took some around 1 minute to send the update to R1. So now R1, when R1 computers are trying to communicate to R3 computers, which belongs to a different subnets, with the help of routing version RIP2, they are communicating. See, PC1 is communicating to PC4, which belongs to different subnet. And now if you are coming to R1 and check the routing table, see here you are getting the routing table that, okay, see here, you're getting the informations and now you are communicating. Okay, and now if you're coming to R3, R3 also you are getting informations regarding those networks. Okay, see here it is subnetted, see /26/26. So only these kind of, when it is subnetted network, so only RIP2 can support those type of subnetted networks. But when we are talking about RIP1, RIP1 cannot support these classless networks. That's why we have, that's why we can use our this subnetted this. Okay, so you can see here, if you will check about this lab, right? Okay, so this lab is totally regarding your subnetted networks. You can see here. Okay, see, this is see /16, right? 10/16 means it's subnetted one. This is also subnetted. So when we are talking about subnetted network, at that time we have to use our RIP version 2. Okay, so we will be talking more on RIP version 2 in our next classes, because we have around 60 to 50 slides in this RIP. So we are up to 20 only. So we have to move around to others. Okay, so you can see here we have what is auto summarization command, why we use auto summarization command. Okay, what is the subnetted networks, sub VLSM labs. Okay, then we will talk about timers. Okay, optimization. Okay, so in our next class, I think we will complete our, because theoretical part is completed now, only we have to work on practical sessions. Okay, then we will be touch in our next session. Okay.